Hello, subatomic ducklings. It's Rick Stevenson, aka Rick, but you may call me Cool Kid Rick for short. And we're here to discuss a formula, a very special formula that you've probably been learning since third grade, or before or after. I don't remember exactly when I learned it, but we've been learning it for a long time. And I bet you don't know how we came to the conclusion that this formula works. Now, what formula am I talking about? Here's the formula. E equals pi r squared. Now, you probably already know this from the title of the video, but think about it. Do you know how we came to the conclusion that the area equals pi r squared? Now, this is the area, for those of you who don't know, this is the area of a circle. Now, let me ask you this. Why? Why is this the area of a circle? This random length, which is a radius, multiplied by this random irrational constant 3.14. Why does 3.14 times r squared equal the area? Well, there's a very simple explanation for this. One that your teacher should have explained to you back in third grade. So let's take a look at a circle.
Bruh.
Okay, now that's not a very well drawn circle. Let me try taking a deep breath, getting my drawing skills out. Circle. More of an oval, but a much better circle than before. Now, what is the circumference of the circle? Now, the circumference of the circle you can get as 2 pi r. Now, that's a pretty basic formula. It is just the ratio of the diameter and the circumference, right? Pi equals the ratio of the circumference and the diameter, right? Diameter is just 2 pi, or the diameter is just 2r, sorry. So 2 pi r equals c. Easy. Now, we have the circumference of the circle here. Let's open up the circumference of the circle and make it a straight line. And let's place the straight line right here. This is a straight line of length 2 pi r. Great, off to a great start. Now, the circle has a center over here, and let's imagine that the center and the points as we move along from the center are made of these infinitely small rings. So, something like this, right? These are infinitely small rings. Now, my drawing skills are still not too good, but imagine that there are infinite rings placed next to each other, the next one being bigger than the rest, bigger than the one before, and together they form a circle like this, right? Now imagine we open up each one of these rings similar to how we opened up the diameter, and we place them in a line right next to the diameter. Since there are infinite of these rings and they are infinitely thin, they're going to be something like this, right? The one right next to the circumference is going to be slightly shorter, ever so slightly. And the one next to that is going to be slightly shorter. And as you see, as you go closer and closer to the center and open up the lines, you get shorter and shorter and shorter lines, infinitely many of them. And if you continue to draw these lines, what you'll get is a shape that you will recognize. Not looking too good, but basically what you get is a triangle, right? As the lengths of the rings get smaller and smaller and smaller, their height will decrease and you'll get a triangular shape like this. So the height of the triangle is 2 pi r. Now, what is the width? The width of this triangle is just going to be the sum of the lengths, the widths of the infinitely small lines. Now, what is that? That's just going to be this line right here. And what is this line? That's the radius. So, this line right here, the base, is just the radius. Now, what's the area of a triangle? Now, remember, this triangle has the exact same area as the circle. All we've done is taken the infinitely many rings that make up a circle and make them into straight lines and place them one after another. So, the area of this triangle, the area is half base times height. So, half base r times height, 2 pi r. Now, the 2 is cancel and you get an area of pi r squared. And that, my little ducklings, is how you get a perfectly delicious pie. I mean, the area of a circle. See you later.